My name is David Joyner, and I work for Udacity helping develop and deliver courses for the Georgia Tech Online Masters of Science in Computer Science program. In this miniature course, I'm going to present the results of an idea we had for scaling expert assessment to large online classrooms. In a traditional classroom, you would have a number of students, and they would complete some assignments, and they'd be sent to a teacher or a grader to evaluate. And that teacher or grader would then generate some evaluations for the students. If you want to handle more students, it means you need to hire additional graders or additional teachers to generate those additional grades. The more students you have, the more teachers you need. That's a problem for many MOOCs because MOOCs are largely built around the idea of reaching more students without hiring more graders. Some courses address this via auto-grading. Students submit their assignment to some computer system in the cloud, and it generates the grades for them. This often works for assignments like fill in the blank or multiple choice, where there's a very closed answer space. It can also work for some more authentic problems like math problems or things that can be graded by simulation or code segments where there's some expected output. But it still keeps a pretty closed answer space. It can't quite handle essays or open-ended projects yet. Those still need a human component to the grading. Some courses try to handle this through peer grading. In peer grading, each student is asked to evaluate a couple of their peers, and the sum of those evaluations is then used to generate some grades. This has some rich pedagogical benefits. We know students learn a lot by looking at the things that their other classmates have done. We also know students learn a lot when they're put in the position of evaluating their classmates, so they actually approach it as the teacher, as the grader, as the critic. And obviously, this helps with scale. When we have more students, that also means we have more graders. If we have fewer students, then we need fewer graders. But there are some drawbacks to this. Studies have shown that peer grading can be reliable compared to expert grading, but only in very specific circumstances. And many of those circumstances are not present in large online courses. Even if the numeric evaluation is consistent with expert graders, graders also play a key role in the feedback process. Written feedback received from classmates is not likely to be sufficient in learning material compared to written feedback received from experts. There's also an issue of student perception in a system like this. It may work in MOOCs that are low cost and don't have an accredited credential attached to them. But what about real bachelor's or master's degrees? Are students likely to view those degrees as reputable if a lot of the grades are just assigned by their fellow novices? And there may also be interpersonal issues here related to retaliation or generosity or meanness. A student could perceive giving their classmate a low grade when they know that they hold their grade in their hands as a mean action. They might want to be generous just to be friendly. Similarly, if one student gives another classmate a low grade, that classmate may have the opportunity to retaliate later by giving an equally low grade, even if the other student didn't deserve it. Some new initiatives attempt to bridge this gap. Some new approaches, including some being presented at the same conference based on this same program, put a computer in between the peer review process and the final grades. These approaches use machine learning to evaluate these peer reviews and identify which ones are likely to be most reliable. But these approaches are still in their infancy, and they don't address the problem of written feedback. So we've covered three options. We've covered traditional grading, which limits the enrollment based on the number of available graders. We've covered automated grading, which limits the types of assessments that can be used. And we've covered peer grading, that limits the presence of expert feedback and may introduce reliability issues. Automated grading and peer grading together may be good enough for MOOCs, but it appears that traditional grading is still necessary for traditional bachelor's and master's programs. But what if we want to do a traditional bachelor's or master's program at MOOC scale? How do we address all these issues at once? The challenge of delivering a traditional master's program at MOOC scale is the exact problem faced when the Georgia Tech OMSCS program started. OMSCS stands for Online Master of Science in Computer Science. It launched in January 2014 as a collaboration between the Georgia Tech College of Computing, Udacity, and AT&T. This program aimed to deliver a real master's degree at MOOC scale via the internet. It aimed to borrow some elements from MOOCs and some elements from traditional education to deliver a rigorous online master's program. Certain portions of the program are very traditional. Students must still apply to Georgia Tech itself and be accepted. It's not open enrollment. Students still register for classes, pay tuition and fees, and they have to meet certain minimum GPA requirements to stay in the program. For the most part, delivery of the courses is the same that it is on campus. Classes are still based around projects and assignments that are similar to the residential program. In fact, in many cases, they're the exact same assignments given to the residential students, and teaching assistants are still used to evaluate the work, give feedback, and guide discussions. And finally, students still graduate the way they do from a traditional master's program. They must complete 30 credit hours, including 15 in one of the program's specializations, and then they have to apply to graduate. All these factors are the same between the online and on-campus programs. The only difference online is that the material is delivered via the internet instead of in person. There are several things, though, that make the OMSCS program unique, both compared to residential programs and compared to other online programs. The first is that it's actually built for the internet. Many traditional distance learning programs just use the internet to recreate the in-person experience. They might live stream a class that you still have to attend at a certain time of day, or they might use teleconferences to facilitate discussions. The OMSCS instead looks for the things that we can do on the internet that we can't do in person, to try and make up for anything that's lost by delivering the program online. One of our other presentations at this conference actually goes into great detail on the different ways building the program for the internet enhances that pedagogical experience. So I recommend checking that out. A second unique element is the increased affordability of the program. The OMSCS program is $170 per credit hour, which is an 85% decrease in tuition compared to out-of-state tuition for on-campus students. Total tuition for the entire master's degree, not per semester, the entire degree, is $6,600. When students take our recommendation and take one class per semester, the program costs about $200 a month, including fees. This makes it by far the most affordable full master's degree that I know of. On campus, the number of students we can admit to the program is limited in large part simply by the size of our classrooms. We have a physical barrier to how big the program can be, and we can't let in more students than our buildings can handle. Online, though, there's no such physical capacity. Adding more students to an online class presents no physical barriers and few technological barriers. And this lets us accept students with much more varied backgrounds than we might see in an on-campus program. We see lots of students who don't come from a CS background entering the program and succeeding when they likely wouldn't have even been admitted to an on-campus program. And finally, and perhaps most significantly, the master's degree granted by the OMSCS program is the exact same master's degree granted by the residential program. There is no online qualifier to it. It is not a separate program. It is not a separate credential. It is a master's in CS from Georgia Tech, the same as anyone going to school on campus would receive. The combination of these elements presents some really unique challenges, though. The increased affordability makes it difficult to just hire more graders to handle the number of students we receive. But the fact that it's the identical degree means that we can't water down the assessments just to meet that scale goal. The projects and the assessments have to be the same online that they are in person in order to promise that it's an identical degree, and yet we have to do this with far fewer financial resources. Fortunately, that first criteria actually helps us in that regard. The internet provides us ways of scaling these assessments to meet these goals, and that's a large part of what I'll talk about today. But to summarize the challenges that this presents, the OMSCS program wanted to provide a rigorous master's degree online, which means we have to provide the same open-ended projects, proctored exams, and authentic assessments that the residential students receive. That means we can't water down the assessments to keep automated grading feasible. We can use a little bit of it, especially when it helps get students rapid feedback, but we can't run the entire program that way. And at the same time, the OMSCS program is an identical degree. Part of the value of a master's degree is the understanding that experts have evaluated a student's work and approved it and granted them that degree. So we can't rely solely on peer grading either. And in fact, right now, we don't use any peer grading. We use peer review to get feedback, but we don't use any peer grading in the program. So those challenges mean we can't run the entire program based solely on automated grading and peer grading. But at the same time, the goal of the program is for it to be very large, for it to remain affordable for the vast majority of students, and for it to scale to very large student bodies. This semester, we have 3,400 students taking on average 1.5 classes each, and they're only paying $510 per class that they take, compared to several times more for traditional programs. While this gives us more resources than traditional MOOC programs, it still presents challenges for traditional grading models. So the question here is, how do we handle assessment while simultaneously trying to build a program that is rigorous, authentic, and accredited, and large, affordable, and scalable?